Welcome to Easy BTech, your guide for BTech and beyond. My name is G. Sampath. I am going to explain the subject VLSI design. Today, we are going to discuss the topic scaling factors of MOS transistor, MOS circuits. Scaling factors for MOS circuit. MOS circuits. Let us see this one. The scaling factor is nothing but dimensions. Scaling factor is a dimensions. Dimensions. Dimensions of MOS transistor. Dimensions of MOS transistor. MOS transistor. MOS transistor scaling. MOS transistor scaling. Like we can scale width parameter, length parameter, width, length, VDD, VGS. So all these parameters are changed. We can change the thin oxide also. Thin oxide. Let us see the mass structure. Let us see this diagram. This is a MOS transistor. MOS transistor. And we have diffusion. This one is a diffusion. SiO2 layer. SiO2 layer. SiO2 layer. After that we have a polysilicon. Polysilicon. Okay. This is SiO2 layer. No. This is the structure of MOS transistor. Structure of a MOS transistor. Yeah, you can see this one. Let's take this NMOS transistor. P-type substrate area. P-type substrate area. P-type substrate area. And N diffusion. Forward lines. Nearer distance. N diffusion. This is N diffusion. N diffusion. Right. This is SiO2 layer. SiO2 layer. You see. This is SiO2 layer. SiO2 layer. And we have polysilicon. This is a polysilicon. Backward lines. Nearer distance. Polysilicon. So we can reduce the dimensions of this MOS transistor. Scaling, reducing. Scaling means reducing. So dimensions of MOS transistor are scaling like a width, length parameter. So this is a width is scaled by this. Width is scaled by alpha. Width is scaled by alpha, and this is a length. Length of polysilicon. So length of polysilicon is scaled by length of polysilicon scaled by L by alpha, and here also the diffusion means this SiO2 layer. SiO2 layer will be scaled by beta parameter. The parameter is beta. Now this diffusion also scaled by diffusion is also scaled by alpha, right? And we have thickness of this one, thickness of this polysilicon is scaled by reducing a parameter. So thickness of this polysilicon reducing by alpha. So W is the width of the polysilicon is scaled by alpha, and length of this polysilicon reduced by alpha. Thickness of this SiO2 layer, thin oxide beta means it is D is reduced by alpha beta parameters, alpha beta parameters. Okay, so W is width of the polysilicon scaling by alpha, length is scaling by alpha, and SiO2 layer scaled by beta, and thickness of this polysilicon by 1 by alpha, and n plus diffusion. So this is n plus diffusion. N plus diffusion is scaled by alpha. Now the other voltages also we can reduce the parameter by beta. So VDD is scaled by 1 by beta, and VGS is also scaled by 1 by alpha. Let us see some scaling factors. Some scaling factors are, let us see some scaling factors are, so one is, let us go one by one. First one is gate area. Gate area. So gate area is AG. Area is polysilicon. Length into width. Area is representation length of the channel, and width of the polysilicon. Length of the polysilicon, width of the polysilicon. So L is scaled by 1 by alpha, and width is scaled by 1 by alpha. This will be equal to 1 by alpha square. Right? There are different parameters are there. Then this will be asked in examinations, mostly in competitive exam also. What is the scaling factors? Like we will be asked gate area and gate capacitance. What we are going to discuss, these parameters will ask in examinations, competitive also. Now, gate capacitance per unit area. Now, gate capacitance, gate capacitance, gate capacitance per unit area. Unit area. Gate capacitance per unit area. So this is C naught. C naught is equal to epsilon oxide by D. Right? So epsilon oxide means so this is epsilon oxide. Epsilon oxide is equal to epsilon insulation, epsilon naught, epsilon insulation, and epsilon naught. So and unit area where L is equal to W is equal to 1, unit area 1. So that's why, so it is epsilon oxide by D only. So W and L is equal to 1. So D is capacitance per distance of this SiO2 layer. SiO2 layer scaled by 1 by beta. Right? We can scaled by this 1 by beta is equal to, this is a beta. Right? Second one. Now, gate capacitance. Only gate capacitance. So capacitance means polysilicon to channel area. Okay, gate capacitance. Gate capacitance. Gate capacitance is Cg. Gate to channel capacitance is Cg. So it is gate capacitance per unit area into length and width. C naught into L into W. C naught into L into W. Right? C naught is scaled by beta parameter. L into W scaled by 1 by alpha square. So 1 by alpha into 1 by alpha. So it is scaled by beta by alpha square. Right? Beta by alpha square. Now we have the fourth one. The fourth one, parasitic capacitance. Parasitic capacitance. Parasitic capacitance. So it is representation of parasitic capacitance. It will be Cx is equal to Ax by T. So Ax is area of the depletion 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 length and width. D is the depletion width. So this is happened in parasitic capacitance. So here there is a depletion is there from here to here, from here to here, source to drain. From source to drain there is a depletion is there. So from here to here there is a capacitance is formed. So from here to here there is a capacitance is formed. Okay, like C1, and some capacitance is formed here. Some capacitance is formed here. So this capacitance is called as parasitic capacitance. Here also some capacitance is formed from gate to channel. Like this is a parasitic capacitance is formed from source to drain. Source to drain. Like Ax is scaled by, so Ax is scaled by 1 by alpha square, and this depletion width is scaled by 1 by alpha. So Cx is equal to 1 by alpha square by 1 by alpha. So this will be equal to 1 by alpha, 1 by alpha, right? Now the next parameter, next mass transistor, charge carrier density. Charge carrier density. Charge carrier density, Q on. Charge carrier density in the channel. So charge carrier density on transistor channel charge carriers are C naught into VGS. C naught into VGS. C naught is the capacitance per unit area into gate to source voltage. Gate to source voltage. C naught is scaled by beta. Previously we are seen. VGS is scaled by beta. So this will be equal to 1. So charge carrier density is equal to 1. Now sixth one, resistance, on resistance, on resistance. So on resistance R on is equal to, it is a L by W, and 1 by Q on into mobility of charge carriers. L is the length of the channel, W is the width of the polysilicon. So L is scaled by 1 by alpha, W is scaled by 1 by alpha. So Q on is 1. So this will be equal to 1. So alpha will be cancelled out. Then it will be, we can scale the resistance. On resistance is 1. It is ratio of L by W 1 by Q on. Right. The seventh one is time delay. Time delay. So time delay is TD. TD is equal to, so directly proportional to R on into gate to channel capacitance CG. So gate capacitance CG. R on is equal to 1. What is the CG? Gate to channel capacitance. Gate to channel capacitance CG is equal to beta by alpha square. So it is beta by alpha square. So time delay is directly proportional to R on into CG. It is scaled by beta by alpha square. So where beta is a parameter which we discussed in CG, gate to channel capacitances. Gate to channel capacitance. So gate capacitance CG is equal to capacitance per unit area into length of the channel, width of the polysilicon. So it is beta by alpha square. Right? Now next one we can see. Next one we can see this one. Eighth one. Eighth one is a operating frequency. Operating frequency. Operating frequency F naught. Operating frequency F naught is equal to, it will be W by L mu into C naught into VDD by CG, right? So W is the width of the polysilicon is scaled by 1 by alpha, length of the channel is scaled by 1 by alpha, mu into the C naught is scaled by beta, VDD is also scaled by 1 by beta, and Cg is scaled by beta by alpha square. You see, alpha and alpha will be cancelled out, beta will be cancelled out. So operating frequency F naught is scaled by alpha square by beta square, alpha square by beta square, right? Next one, the ninth parameter, saturation current. Saturation current. Saturation current. Saturation current. It is IDSS. IDSS. You can see in the previous operating frequency, it is time is equal to reciprocal of frequency. Okay, reciprocal of frequency, where f is equal to 1 by t. F is equal to 1 by t. So t is equal to, time delay is equal to beta by alpha square, beta by alpha square. Now 1 by time is equal to frequency, right? 1 by time is equal to frequency. So time and frequency both are reciprocal. You see, time delay beta by alpha square, operating frequency alpha square by beta. So it is reciprocal, right? You can remember that. Now IDSS, saturation current. IDSS, saturation current is equal to, we can write this C naught into mu by 2 W by L into saturation current means VGS minus VT. VGS minus VT whole square. VGS minus VT whole square by 2. C naught is a capacitance per unit area. It is scaled by beta, and W is the width of the polysilicon scaled by 1 by alpha. Length is the polysilicon length. It is also scaled by 1 by alpha. VGS minus VT is scaled by 1 by beta. So 1 by beta whole square. So this will be alpha will be cancelled out now. Beta into 1 by beta square. Square and beta will be cancelled out though. So saturation current IDSS is scaled by 1 by beta, right? Now next one, current density. Current density. Current density. Current density. Current density is defined J. Now current density J is equal to current per unit area. So IDSS by gate area AG, right? Now IDSS means 1 by beta. Now AG is 1 by alpha square. 1 by alpha square. So this is scaled by alpha square by beta. It is scaled by alpha square by beta, right? Let us see the next one, the 11th one, energy per unit area, energy per gate. Energy per gate, energy per gate, this is defined EG. EG is equal to CG by 2 into VDD whole square ma. VDD whole square, right? VDD whole square. So this will be equal to CG. What is the CG? CG is beta by alpha square. CG is beta by alpha square, and VDD is scaled by 1 by beta, 1 by beta square. Now beta by alpha square into 1 by beta square. So beta and square will be cancelled out. So this will be 1 by alpha square into beta. So this is the energy per gate area. Energy per gate area. Let us see the another one. Power dissipation per gate area. Power dissipation per gate area. Power dissipation. Power dissipation. Power dissipation per gate. Power dissipation per gate. It is PG. Power dissipation per gate. So dissipation across the gate terminal in a circuit. So there is a two ways of power. Static power PGS plus PDS. It is a dynamic gate power. Dynamic gate power. You can say PGD. PGD. So PGS is static power. Static power. PGD is the PGD is the PGD is the dynamic power. Dynamic power. Right. Static power is a constant power. So static power is a constant power. Static power is the constant power. Static power. Static power is nothing but VDD. It is a constant power that can apply. So it is called static power. Dynamic power is the input. Dynamic power. The power generated from the input voltage. Dynamic. Dynamic power is nothing but the power generated from the input. V in voltage we are applying. Input voltage. Right. Let us see this one. Let us see this one. So PG is equal to PGS plus PGD. Right. The static power PGS is scaled by VDD whole square by R on. So this can be defined. This can be defined. We know that power is equal to I square R. Power is equal to I square R, where I is equal to V by R. I is equal to V by R. So V by R square, V by R whole square into R. This will be equal to V square by R square into R. Now what happens? R and this square will be cancelled out. This will be V square by R. V square by R. So V means VDD. Static power means supply voltage VDD. Supply voltage VDD. So VDD whole square by R. R is a resistance, the on resistance. Right? On resistance. Now PGS is VDD whole square by R on. And this dynamic gate power PGD, dynamic gate power PGD. PGD is equal to PGD, it is equal to EG into CG. So EG is the average electric field gate to channel. So average electric field, and CG is the gate to channel capacitance. It is gate to channel capacitance. Gate to channel capacitance. Now, so both are, so VDD whole square means this is 1 by beta square. This is 1 by beta square. So operating frequency we have like not CG. This one is we have operating frequency. If not, Cg into f naught ma. Cg into f naught, right? Operating frequency. F naught is the operating frequency. Now, f naught is the operating frequency. F naught is operating frequency. Operating frequency. Right? What is the operating frequency? F naught is equal to F naught is scaled by alpha square by beta. Second. F naught is a beta by F naught is alpha by beta square. Alpha square by beta. Right? So both are it is scaled by 1 by beta square. Both are scaled by beta square. 1 by beta square. So it is scaled by beta square. Let us take this one. Both are scaled by power per gate area. So PG, both PGS and PGD are scaled by 1 by beta square. 1 by beta square, right? The next one is power per power power per unit area. Power per unit area. Power per unit area. We can say PA is equal to PG by AG. So PG is average scaled by 1 by beta square. AG is scaled by 1 by alpha square. This will be alpha square by beta square. Now the last one, speed power speed power product. Speed power product. Speed power product. Right? Speed power product. PT is equal to PG into AG. Like we can say it is a PG into CG. Right? It is 1 by beta square. CG is alpha square by beta by alpha square. Beta by alpha square. So beta and square will be cancelled out. It is 1 by alpha square by beta. Okay. So these are the 14 parameters for 14 parameters for scaling factors. Right? Scaling factor is the changing in the dimensions. Changing of the dimensions, length and width. The parameter is alpha and beta. So width, length, VDD, VGS, we have different parameters are here. So first one is gate area, gate capacitance per unit area, parasitic capacitance. Right? Now we have charge carrier density, on resistance, time delay, and operating frequency, saturation current, current density, and energy per gate area, and power per gate area. Right? 1 by, then average is 1 by beta square, power per unit area. So PG by AG, and last one, speed power product. So it is PG into CG. So power per gate area and gate capacitance is 1 by alpha square beta. So these are the very important in examinations and also in competitive examinations. Thank you. Please subscribe the channel and like and inform your friends. Thank you.